can you see my screen? Screen is visible? Yeah, Ratika, screen is visible? Screen
Yes,
is
sir.
okay, okay. So you have to, yeah. So we'll start. So today we will look for the numericals, like how to calculate the dimensions and other factors in the machine design setup. We'll look for the different this thing. So let me introduce the question by the time people arrive. So let me write the questions. So yeah, yeah. So we'll go for the okay. Something is there. No problem with this. Now it's okay. Numericals. So, the numericals as we are seeing, find the value of stated. So let's go for this problem. Two numericals will do. Determine the main dimensions. Determine the main dimensions of the stator core of the stator core number of stator slots, number of stator slots, and number of stator conductors, and number of stator conductors, for a 11 kilowatt, for a 11 kilowatt 400 volts 3 phase 4 pole 50 hertz 50 hertz 50 hertz delta connected, okay, delta connected delta connected induction motor, delta connected induction motor. Now assuming specific electrical loading, so that is ampere turns, assuming that specific electric loading electric loading, in bracket we can write ampere conductors, is equal to 23,000 ampere conductors per meter, okay, and specific magnetic loading as, and specific magnetic loading as specific magnetic loading as 0.45 Weber per meter square. So okay, full load efficiency is 0.85. So what happened? Eraser. Yeah, full load efficiency is 0.85. So this is the full load efficiency is 0.85 and power factor is 0.88 and power factor is 0.88. This is my power factor and that is my full load efficiency is 0.88. Take the core length equal to pole pitch. Take the core length equal to pole pitch. So one thing we have done, pole pitch would be take the core length equal to pole pitch, and then the stator and the stator is basically, I told you about the single layer and the double layer winding. The stator has is the stator the winding is a double layer winding. So the winding in stator is a double layer winding. So this is the question. So we end the question here. So when we look to the question, so what are the main factors from the question? What is the given data? So if I want to write the given data here itself, if I'll change the color. So let's go for the given data. Given data. So as far as the given data is concerned, so the number one thing is that what is the power? So its power is 11 kilowatts. So we can write power is equal to 11 kilowatts. Okay. So this is our given data. Another factor that is mentioned over here is your voltage. So now see here, 400 volts and it's delta connected. So in delta connected, phase voltage and line voltage would remain same. So your phase voltage in the delta connected setup, if it was star connected, then you had to divide this 400 by root 3. Now it's delta connected, no need. Three phase. Number of poles, here it has mentioned number of poles is equal to 4. It's given there. And your frequency is given. Frequency is given 50 hertz. So frequency is given 50 hertz. Apart from that, your it's delta connected, and then your ampere conductors is given 23,000, and your average flux density, that is B average, it is also given 0.45 Weber per meter square. Now what is your efficiency is given. Okay, so your efficiency is also given. Your efficiency is how much? It is given efficiency is 0.85. Okay, your power factor is also mentioned. Power factor is 0.88. What is happening? 0.88. Okay, apart from that, your L is equal to tau. So L is equal to your length is equal to pole pitch. So what is your basically your tau L is equal to Z. So tau pole pitch would be, the pole pitch is what? The circumference. Tau is pi d by p, which we have seen in the DC machine also. So this is the, and moreover this is a double layer winding. Okay, so let's go about the problem. So first of all, let's see the input kVA. Okay, the input kVA would be how much? Now let's go about the problem. So let's see the input kVA. So if you need to calculate the input kVA, so you can calculate from that formula which I have already shown you. Input kVA is equal to kW into efficiency by cos phi. So your input kVA you can calculate. Kw is here 11. Okay, efficiency is 0.85 and your power factor is 0.88. So you can get input kVA. Input kVA would be 11 divided by your efficiency. Efficiency is how much? 0.85, and you have your cos phi 0.88. Now if you calculate this, what value you are getting? Please tell me. I will not write the value. So what is the value you are getting? Tell me.
14.70, sir.
Yeah, 14.7, 14.7 kVA. Okay, this is 14.7 kVA. Now, one more important thing over here is that for your output equation, okay, everything is mentioned apart from kW. kW is not given. So when kW is not given, you should roughly assume it around 0.96. So this you can safely assume, okay, because kW is basically kp into kd. Okay, so if you substitute that m sine beta, that here you have this kp is how much, this is cos alpha by 2, and that into that m sine beta by 2 divided by n sine beta by 2, that formula if you substitute, it will come around this 0.96. So now no need to substitute those things, it will come around this. So usually we take it around 0.96. Now you know the output equation formula. In the output equation, you know the C naught value. C naught you have seen from the previous, we have calculated, it's around 1.11, 1.11 into pi square into pi square into BAV. Okay, okay, wait 1 second, this is the problem. I'm eraser into, okay, very sensitive this board, into BAV. Okay, into ampere conductors into AC into kW and in 10 power minus 3. So you have all the values, you can substitute. You have BAV value also you have. See here, BAV value is there. The BAV value is 0.45 Weber per meter square. So you can write 0.45 Weber here. You can write 1.11 into pi square into 0.45. Ampere conductors also you have. Ampere conductors value is here 23,000. So you can write this 23,000. kW I told you to assume 0.96 into 10 power minus 3. So tell me the value. Hmm? Tell me this value. C naught value. Calculate it. So how much you will get? Yeah. Substitute and please sit with the calculator now. It's like high time. Okay. What value you are getting? Yeah, Dikshita, tell me. Jaswant. Yeah, Ratika, did you calculate 1.11 pi square into 0.45 into 2?
So 108.8.
Yeah, correct. 108.8. So you will get around 108.85. Okay, this is the value I am getting here, 108.85. So now you got the value of, now the basically what you are interested to get is that you want the main dimensions D and L, and then you want the total number of stator conductors and the number of stator slots. So once you got this, so you know the synchronous speed, that formula also I've shown you. Now the synchronous speed, that is your synchronous speed in RPS, if we see, is equal to, that is your ns is equal to, you tell me, ns is equal to, in terms of c, ns is equal to 2f by p. So f is 2 into 50, poles are 4, so it would be around 25. This is 25. So this you got the synchronous speed also you have, you got. Now the volume of the machine, that is volume of the machine would be your volume of machine, volume of machine, if you need to calculate, is equal to d square L. So from the previous formula here, C naught is, this is basically C naught is equal to 1.11. So basically what is the output equation? In terms of output equation, if I want to write, So my input kVA would be equal to, input kVA would be equal to what? It would be equal to C naught D square L N S. Okay, this is the equation because C naught is this value. Which we can C naught D square L N S. Finally, we write in terms of that. Now, if we want to calculate the value of D square L, so the D square L value we can write in terms of input kVA divided by T. Input, this is, see, it can be written as input kVA, okay, divided by C naught NS. That would be our D square L. Look at this equation. That same thing. D square L I have kept here, input kVA divided by C naught NS. Nothing here. From here only, if I will write D square L, I will keep there. This input kVA divided by C naught and NS. C naught and NS. Nothing but the same thing I have written over here. So now we have the values of input kVA we calculated. Okay, now you can tell me the value. Tell me the value. You have all the values, you can calculate and let me know the value. So the value for the input kVA we are having is 14.7. Constant value also we saw, NS value also we saw. So this input kVA value, here we have seen input kVA in the very first input kVA was 14.7. So this 14.7 we can substitute over here in 14.7. C naught value also we saw. C naught we just saw 108.85. So we can substitute here 108.85. NS also we just now we calculated NS here 25. So we can substitute here 25. So we get the value of D square L. Tell me what is the value you are getting while substituting this. So if you are substituting this, so you will get a value of 5.4 in 10 power minus 3. Okay, you are getting this, Radhika? 5.4 into 10 power
Yes.
minus 3. Okay, this is the value you will be getting, 5.4 in 10 power minus 3 meter cube. Now one important thing is that, so he is saying that L is equal to Z, length of core is equal to pole pitch, and this Z is equal to pi d by P. Okay, he's telling like that. So we can safely say pi d by P. So P is 4. So and now you can write down that pi d by 4. Pi by 4, if you see, it will come around 0.785 d. I'm correct? Do pi divided by 4. If you do, what value you will get? Pi divided by 4, you will get 0.785 d. Correct now? Yes. So once you have, now you know that our L is equal to 0.785 d. Okay, and our D square L is equal to 5.4 in 10 power minus 3, that you have seen from this part. So you have two things. Now you can do one thing. Okay, you can get the value for this D. So you can substitute the value of here, from here 0.785 d. L is the value 0.785 d. So we can write D square into 0.785 d is equal to 5.4 in 10 power minus 3 meter cube. So this d square, this would become 0.785 d cube is equal to 5.4 in 10 power minus 3 meter cube. So now if you substitute in this equation, I'll write with a separate color over here. So the finally your d value which you will get is around, so your d would be the cube root of 5.4 in 10 power minus 3 divided by 0.785. So this would be the value of d. This happens to around 0.019 meter. Okay, so the d value will get 0.19 meter. Now the d value you got 0.19 meter. So you know that L is equal to 0.785 d. So you can write 785 into 0.19, so you get L value. So L value will get around 0.149 meter. Okay, this was about the D and L value. So what if we go back to the question? Let's look what it's telling. Determine the main dimensions. The main dimensions are D and L. So we got this of the stator core, number of stator slots and number of stator conduct. See, but it is also asking of the main stator core, but number of stator slots. Okay, this we have to do, and number of stator conductors. For now, number of stator slots and number of stator conductors, that is yet to be done. Now once we got the this main dimensions, now let's move to find the other values. So the other values for this would be, see, number of stator slots, we have to calculate the turns per phase. See, first of all, the number of conductors, that is ZS. I told you if it is a three phase machine, it would be 6 times TS. Okay, 6 times turns per phase. So ZS is 6 times. For a single phase, ZS is equal to twice T phase. So first of all, that means we have to calculate this T phase. In order to calculate this T phase, we can see we have your ES is equal to 4.44 F pi m kW, okay, into T phase. Now, if we want this T phase, we can calculate T phase is equal to ES divided by 4.44 F phi kW. So ES we have this value, we have 400. This is 4.44. F is 50. Now your flux they have mentioned or not. Now flux you have to calculate, because average flux density they have given. Average flux density BAV is mentioned. BAV how much they have given? 0.45. So this is given 0.45. So 0.45. So 0.45. So BAV is basically what? Flux by area. So flux by area. So flux would be BAV into area. So you have to calculate the flux. So basically the BAV into area you can, because the flux per pole is needed. So it would be basically the area, if you see, area would be into pi dl. Okay, but this area is for what? Is for the entire machine, but you are interested in flux per pole, so you have to divide this by the number of poles. So from here BAV into pi dl, so here you maximum flux per pole, if you want, that would be your BAV into pi dl divided by p. So d value you have, L value you have, BAV you have 0.45 into pi divided by 4 into d into L. This you can write 0.785. This you can write, this is equal to 0.45 into pi by 4 is 0.785 into d value you just now saw 0.19. This value is 0.149. So now if you calculate the value of x, it will come around 0.01. You calculate it, is it 0.01? And confirm 0.01 Weber you will get. So in the earlier equation for the T phase here, you don't have this value, so you can write 0.01. Obviously kW is 0.96. You will get the T phase value. So you get the T phase value. So the T phase value you are getting is around 188. So this is my T phase value, around 188. So now I am interested to know the number of stator conductors. Obviously, my number of stator conductors is 6 times T phase. ZS would be, because it's a three phase machine, ZS is equal to 6 times T phase. So it will be 6 into 188. So this would be equal to 6 into 188. And I will arrive at 1128. This would be my answer, 1128. Now I got the total number of stator conductors. So this thing is also done. So total number of stator conductors is equal to 1128. Now the important thing is the stator slots. See, to calculate the stator slots, you will go for the number of poles and the phases. See, there is a formula for this. How to calculate the stator slots? Number of stator slots. So this formula for number of stator slots is given as we should keep this something rules. Okay,
The Z is coming 1126 now, sir.
1126. 188 into 6 is how much? 1126. Wait, 188 into 6. Wait, I will see. 48, 4,
Okay, sir,
6.
I didn't round up.
No, no. 188. Yeah, it is 1128 only. I just saw. Okay. Maybe somewhere you did not that 188 where I have taken, you have not rounded, because you cannot have number of turns in terms of an decimal value. You have to round off to the nearest integer value. Okay, got it?
Yes, sir.
Okay. So this is the value of the Z. So now the number of stator slots, if you are concerned, see, number of stator slots, we write in terms of P, Q, and S. Okay, so P, Q, and S. So we have P as the number of phases. This would be represented by the phase. So this would be always 3, and Q value we need to substitute. So Q value can be either 2, okay, or 3, or S. Okay, Q, if you keep it 1, it will not have any change, because it will, see, for example, if you are multiplying anything with 1, it will remain same. So we took take this value as QS is what, basically Q S is, we are interested to know, sorry, this is the number of, wait, where I want, this is the, if you take this phase and this is a number of poles, so this will also not change. Number of poles would be 4, or you can write this as phase and this as pole, one and the same thing. P is equal to pole. So see, P is pole, so the number of pole is 4. Okay, Q value is varying for the slot dimensions. So value is varying to accommodate the windings in the slot. So we have seen the best winding slots, best power factor, another factors which in the previous class I mentioned you. For that we design for the best power factor, we have this L by Z ratio. This for the best efficiency, we have this. For this we have. So similarly here also, if you see stator slot pitch, so the stator slot pitch would be represented by, so the stator slot pitch that is called as YSS. In some books, lambda SS, YSS, that is your pi d is your circumference, 2 pi r, that is d, you can write 2 pi r, divided by, in that circumference, how many stator slots you can accommodate. So this is pi d by SS, this value. And this value for an induction motor should be between 1.5 to 2.5 centimeter. Now herein the designer's mind comes into play. Now Q you are varying from different values, 2, 3, 5. Now you see here P is equal to 4, and number of poles will not change, number of phases will not change. So you have constant. 4 into 3 is constant. Now into 2, if you do it, it becomes 24. Okay, so this is number of stator slots, that becomes 24. So if you do pi d by 24, that is your pi d by 24. So you have pi d value, you have calculated 1.9, divided by 24. So this is 1.9 meter into 100. If you give, it will become pi into, in terms of centimeter na, it will become pi into 19 by 24. So tell me the value, pi into 19 by 24. How much you will get? Pi into 19 by 24. Do fast. Hmm? Tell me the value. Yes, please. Yeah, Ratika, tell me. Pi into 19 by 24. You are getting around 2.5. How much you are getting? Yeah, pi into 19 by 24.
Yeah,
Tell me.
2.48.
2.4. So you are getting the value of 2.48, or almost, it's like 2.5. Okay, almost nearing that value. So the range is between 1.5 to 2.5. So okay, so we have to have between this range. We cannot exactly touch here. Okay, so this value can be substitute here? No, I don't think. Okay, we have to have it in the range. Okay, now if you go for if you change the q value to 3, so it will become 4 into 3 into 3. So it will become 36. Now here it will become how much? Pi pi into 19 by 36. So what is the value you are getting? Pi into 19 by 36. I think you are getting 1.6 centimeter. 1.6 centimeter. So okay, 1.6 centimeter is within this range. 1.6 centimeter. Now if you take the number of slots as 4, if you take the number of slots as 4, here it will become 4 into 4, 16. 16 into 3, 48. So it will become how much? Pi d. So it will become pi into 19 by 48, and this will become your stator slots will become here. SS would become here around 1.2 centimeter, which is not desirable. Not desirable because it does not lie in 1.5 to 2.5 range. So if you still go ahead, so pi into 19, if you take q value as 5, so similarly it will become 4 into 3, 12. It becomes 60. So it still drops down, so it does not remain in the range. So the value that is in the range and is comfortably in the range is for q is equal to 3, that is pi d by 36, that is 1.6 centimeter. So we can safely say that number of stator slots SS is equal to 36 is selected. So we can write number wait, eraser. We can write number of stator slots SS is equal to 36 is selected. So what we saw is that from the formula we came to know how to select, how to go about the selection process, how to select, the number of stator slots, how to calculate the number of conductors from the formula which we have studied. So in the examination, these problems can come for your mm, 10 marks, 12 marks. Now again, if you want to like cross verify it, okay, number of stator conductors per slot. Okay, so see, we can see therefore something. Okay, yeah. So if you want to cross verify, you can see that therefore the number of stator conductors per slot. If you want to see number of stator conductors per slot, it would be equal to ZSS, that is would be equal to ZS by SS. So ZS you saw 1128, SS you saw is 36. Now if you want to see the number of stator conductors per slot is around coming around 32. So this is the 32, that is the slot number. So and if you want to verify from this whether what calculations you have made, see, this is the theoretical calculation. Actual number of stator conductors, if you want to see, actual number of stator conductors would be from this very formula, actual ZSS, ZS by SS. So ZS value would be actual number. So ZS would be equal to ZSS into SSS. So SSS you have calculated is 36. ZSS you just now saw from here calculation, you made it 1128 by 36 is 32. So you just see 32 into 36. So this is around 1152. Okay. So one actual number is 1152. Otherwise, what you theoretically with the formulas and everything you calculated uh, was around 1128. Okay. Here, if you see from the turns per phase. From the turns per phase formula, you calculated a total number of stator conductors is 1128. But what happens exactly? Why there is a variation in this? Because there is a lot of material that is getting involved, conductor and all that thing. This is all not taking the other mechanical properties, windage losses, stray losses into account. So the number of stator conductors actually required would be little more compared to what we are calculating by converting the electrical quantities into mechanical quantities and magnetic quantities into mechanical quantities. So this is the way how do you really go about the calculation. If you have any doubt at any point, please let me know. For having any doubt, see, I'll give you one homework problem today. Okay, so you have to do. So we'll read the question. Determine the main dimensions of the stator core. Okay, so this was about D and L, number of stator slots. Number of stator slots was okay, and number of stator conductors. Okay, for a 11 kV 400 volt 3 phase 4 pitch 50 hertz delta connected induction motor, assuming specific electrical loading AC to be 23,000 ampere conductor per meter and specific magnetic loading as 0.45 Weber per meter square. Full load efficiency is 0.85 and power factor is 0.88. Take the core length equal to pole pitch, that is L is equal to Z or L is equal to pi d by P. The winding in stator is a double layer winding. Given data is P is equal to 11 kV, ES is equal to 400 volt, BAV 0.45 Weber per meter square, L is equal to Z is equal to pi d by P. In some books they write it tau, some books they write it Z. I have used tau here, then Z here, same thing, no problem. Don't get confused. P is equal to 4, F is equal to 50 hertz, and your efficiency, this is not N, this is basically efficiency. Efficiency is equal to 0.85, power factor 0.88. Then we just saw the input kVA is equal to kW, efficiency by cos phi. kW was given 11, efficiency 0.85, 0.88. Calculated the value of input kVA 4.7, and then kW was missing, so we assumed it around 0.96. Put in the output equation C naught, where 1.11 pi square BAV AC into kW and 10 power minus 3. So we saw that BAV value was given 0.45, AC value was given, kW value was assumed, got the value of output coefficient 108.85, synchronous speed in RPS, NS is equal to 2F by P, 2 into 50 by 4 is equal to 25. So your D square L input kVA was C naught, D square L NS. So D square L we kept over here, input kVA divided by your C naught into NS. So input kVA value was there, C naught value was there, NS value was there. So volume of the machine D square L was input kVA by C naught by NS. So input kVA we calculated 14.7. C naught value we substituted, that's also we calculated, NS also calculated, got this value. And there was one relation, L is equal to Z, that is pi d by P, pi by 4. I took it as 0.785 in times D, substitute back here. So it become 0.875 d cube here, 0.785 d cube is equal to 5.4 in 10 power minus 3. Then d cube is equal to under root of 5.4, 10 power minus 3, 0.785. From here I got the value of D, 0.19, and then L is equal to 0.785 into D. Substitute the value of D here, got the value of L, and then the stator conductor ZS is equal to 6 T phase, or in a single phase it is 2 T phase, 3 phase it is this thing. So T phase value, for getting the T phase value, I wrote the equation ES is equal to this equation over here. ES is equal to 4.44 F phi kW T phase, or T phase is equal to ES 4.44 F phi kW. All values we had except phi. So phi value I calculated here, BAV phi by A. and A is pi d L by P. P why? Because flux per pole, maximum flux. This is the maximum flux per pole. So that maximum flux per pole we saw over here, maximum BAB 0.45 pi by 4. Because of P, that 4 value came, D into L we had. I substitute back, I got the value of 0.01 Weber. So this 0.01 Weber I substitute back here, got the value of T phase around 188, and the Z value is 6 times T phase. So 6 times T phase, if I you substitute here, so 6 into 188 would be 1128. This is the value of Z phase. Now I was interested to number of stator slots. For this, I told you number of phases, number of poles, and the Q value is the how many slots you will accommodate. So it cannot be one. So from 2, 3, and 5. So we try to substitute these values over here. So when I substitute two values, so I just saw the slot value, that is stator slots, can be accommodated in this, and this formula is here, ys, that is how many slots can be accommodated in a circumference. Ys is equal to, just like the pole pitch value pi d by p, but here it is the number of stator slots that can be accommodated in this geometry. So ss is stator slots, and this is the number of stator slots that can be accommodated by ss in the geometry, and pi d is the circumference. So ss value we just saw, pi d. Ss value here, this is the value of how many stator slots. Ss was I wrote in terms of p, q, and s. P is the poles, okay. Q value can be from 2, 3, and s is the number of phases value we saw. So this was fixed. Number of phases is 3, number of poles was 4, so only Q was varying. So I varied this value, and the range for this was 1.5 to 2.5. First I put the value for 2, I got 24. It was around 2.5 centimeter. I neglected because it cannot be exactly touching. Then I substituted other value, it was 1.6. I took to, okay, it's okay. Then another value, if I substituted, it became less than 1.5. So I chose 36, the number of stator slots to be 36. So here I have seen number of stator slots SS to be 36. So the number of stator conductors, from this also I can calculate, that is my number of stator conductors, like ZSS would be ZS by SS. So ZSS was like 1128 by 36. It's coming around 31.3, which I took to 32. So because so then ZSS 32 into 36, 1152. This is the actual number of stator conductors. So any doubt you are having? Anyone? Ratika? Jaswant? Ratika, are you there?
Yes, sir.
Any doubt you are having anywhere?
No, sir.
Anybody? Dikshita? Diksha? Monica? Are you there, Monica?
Yes, sir.
Yeah, are you having any doubt? There are two Monicas in the class, Monica BR and Monica V. Huh? Monisha? Huh? Yeah, any doubt you are having? Afsa, you are having any
No,
doubt?
sir. No doubt, sir.
No,
Chiranjeevi?
sir.
Chiranjeevi? Chandramoli, you did not give your flip class. What about your flip class? Chandramoli? Joel, are you there? Kishore Kumar?
Yes, sir.
Are you having any doubt anywhere? Tell me. Kishore Kumar?
No, sir.
If you're not having, okay, then we'll move to the next thing. Gayatri, are you having any doubt anywhere? Gayatri?
No, sir.
Now it's clear, right?
Yes, sir. Now it's clear, sir.
Okay, nice. Okay, yeah. Earlier I was also feeling very uncomfortable. This is very comfortable. Okay, so fine. Now one more problem. I'll write a background. I'll do this rules. Rules you are like find the value. Find the value of stator stator diameter, stator diameter, and core and core length of air. 7.5 kW, 220 volt, 50 hertz, 4 pole, 3 phase, 3 phase induction motor. I'll write as IM. Okay, induction motor for best power factor, for best power factor given specific, given okay, specific magnetic magnetic loading, specific magnetic loading as 0.4 Weber per meter square, specific electrical loading, specific electrical loading, oh sorry, specific electrical loading as 2 to 22,000 ampere conductor per meter, full load efficiency, full load efficiency is equal to 86%, 86%, and full load power factor, and full load power factor is equal to 0.87, 0.87. Okay, so very simple question. Only you have to give the value of stator diameter and core length, that is D and L value. So the given data, what is the given data over here? If you see the given data, you have given data. What is the given data? You have P is equal to how much? 7.5 kW. Okay, you have your ES value is given, ES is equal to 220 volt. Okay, you have your frequency value, your frequency value is 50 hertz, so this is 50 hertz. You have number of poles is given 4. Okay, then this is three phase. Best power factor, you saw that for best power factor your Z value was equal to 0.18, 0.18 L. This is for what? For be, best power factor. Okay, this value is for best power factor, and other values what you are having is for best power factor you are having this, and you have BAV value. BAV value also given is equal to how much? 0.45, sorry, 0.4, 0.4 Weber per meter square. Okay, and ampere conductors you have written, efficiency is 86%, power factor is your power factor is given. See, power factor 0.87 and efficiency is 0.86%. So now what you want to do from this problem, you want to calculate the value of D and L. So you need to find this value, D value and L value. So how do you go about D value? What is it? Highlighter brush. Okay, D value and L value. So your input kVA, if you want to write input kVA is nothing but your kW divided by efficiency into cos phi. So this kVA value, if you see from the previous equation, similarly you do that. So you'll kW value is given 7.5. So you can write this here. You can see E value is 7.5 here, 7.5 kW. This value substitute 7.5 in this equation, so it would be 7.5. Efficiency is also given. Efficiency is given 0.86. Okay, cos phi is also mentioned 0.87. So 0.87. So you get the value of input kVA. So you get around 10.02 kVA. So this is the value you get, 10.02 kVA. Now you have to see, I told you kW value you will assume 0.96. So you remember this, assuming if kW is not mentioned, if it is given, then no problem. If it's not mentioned, then you will take this. So C naught is equal to 1.11 pi square BAV AC kW in 10 power minus 3. So 1.11 into pi square, BAV value is given 4, this value is given 22,000 kW 0.96 into 10 power minus 3. So the total value which you will be getting is around 92.55. This is the C naught value. Again, like the previous problem, you saw NS is equal to 2F by P. So here again NS would be equal to 25 because this is 2 into 100 divided by 4. So 2 ones are 2 twos are, so 200 by 4. 200 by, sorry, this is 50 now. Frequency is 50. 100 by 4. This would be 25 RPS. 25 RPS. Now volume of the machine, volume of the machine is equal to d square L, and d square L you just now saw, d square L is what? Input kVA divided by C naught into NS. So input kVA value you just now calculated, that was 10.02, and your this thing constant value also you just now saw, what was that? 92.55. So you substitute that in the equation there, 92.55 into 25. So that would be around d square L value you will get. D square L value will get around 4.33 in 10 power minus 3 meter cube. Now for best power factor, Z is equal to 0.018 L. What is Z? Z is nothing but pi d by P. So this is equal to 0.18 L. So pi d by P. So pi d by P is 4 pi by 4 pi d by P, pi by 4 into D basically is equal to your pi d by P is equal to your square root of 0.18 L. If you square both sides, you'll get pi d by 4 whole square would be equal to 0.18 L. So you get here pi square d square by 16 is equal to 0.18 L. In other terms, you have your d square is equal to 0.18 L into 16 divided by your pi square, or so d would be equal to square root of 0.18 L into 16 and square root of pi square. So this you can write d is equal to square root of 16 is 4 square root of 0.18 L divided by your pi. So the d value you are getting here from this would be around, so calculate the d value and let me know what is the d value you are getting. Yeah.
So can you show the previous page, sir?
Which slide? Previous slide, huh? Yeah.
Yes, sir.
Yeah, here. Pi d by P is equal to 0.18 L here. From here you have to substitute there. So you can safely write, or in other terms, if you don't want to do all that because you want the value of L in terms of D, so you can also write like this. Okay, no need to do all that jagran, okay, because it again complicates the things. So here we'll rub this. Okay, what we want is we want the value of L. So the value of L in terms of D, if you want to express, so we can express it here. See, 0.018 L is equal to pi d by 4 whole square, or other terms L is equal to pi d by 4 whole square into 1 by 0.18. So this thing also we can write. So once we are writing this thing, so we get L in terms of D. So the L in terms of D value, you will get around, you can write this, the pi, we will keep this in terms of this. So it becomes, basically what it becomes is that pi d by 4 whole square. This is basically here. um, I'll rub here. Okay, so this thing here you can write L is equal to pi d by 4 whole square divided by 0.18. So if you simplify this, you will get around L in terms of D, you will get around L is equal to point 343 D square. Now you substitute this L in terms of D, so you will get around 3.43. You will get around 3.43 D to the power 4 is equal to 4.33 into 10 power minus 3. So you'll get fourth root of 4.33 into 10 power minus 3 divided by 3.43, where you will get around 0.186 meter this, and similarly you will get L 0.343 d square. So here you will get 0.343 into 0.186 ka whole square. So this becomes around 0.119 meter. This is the answer. So you can please give the attendance, okay, and try to practice this question, okay, because there is some mathematics. So, and you join for the HOD's class. So we'll be winding up the session. I'll stop recording.
Sir, for internals, what are the questions, sir?
Internal, when is the